Have you ever stopped to think about how the internet just works? How it seems to know exactly what you want almost before you do? Well, there's a hidden language behind it all, an invisible engine that organizes pretty much all the information in the world. And that language is SQL. Today, we're going to peek under the hood.
I mean, think about that for a second. You ask for something super specific, comedies from the 90s, and bam, in less than a blink of an eye, you get a perfect list. That's not magic. What's happening is a lightning-fast conversation between the Netflix app and this giant digital library, and the language they're speaking, that's SQL.
So, here's our game plan for today. We're going to start with the basics. What is this language of data? Then, we'll put on our architect hats and learn how to draw up the blueprints for information. After that, we'll see how to actually manage the contents inside our structure. Then, the really cool part, asking smarter questions to find things you didn't even know were there. And finally, we'll connect it all and see why SQL pretty much runs the world. All right, first things first. What is SQL, really? Well, you can think of it as having two major jobs when it comes to dealing with data. Its full name is Structured Query Language. Yeah, it's a bit of a mouthful, but all it really means is that it's the go-to standard issue language for talking to databases. If you want to build a database, put stuff in it, change that stuff, or ask questions about it, you're going to use SQL. It's the universal translator. And this right here is the best way to think about those two jobs. On one side, you have DDL, the data definition language. This is you as the architect. You're drawing the blueprint for a house, saying where the walls and rooms go. You use commands like create. Then you have DML, the data manipulation language. This is you as the homeowner moving furniture in, taking things out, and just generally managing the contents of the house. You use commands like insert and select. You got to build the house before you can live in it, right? Same idea. So let's stick with that architect role for a bit. Before we can do anything with our data, we need to build a place for it to live. And that's where the DDL tools come in. Building a table in SQL is actually super logical. Step 1, create table student. You're basically just giving your new data a home and a name. Let's call it student. Step 2, you decide what kind of information you're going to store. Like we need a number for their roll number and some text for their name. And finally, step 3, you set the ground rules, the constraints, to make sure the data stays organized and clean. And those materials and rules are really important. Data types just tell the database what kind of stuff to expect. Is it a number, an ent? Is it text, a varchar, a date? And constraints are like the laws of your little data city. A primary key is huge. It makes sure every single student has a totally unique ID so you never get them mixed up. And a rule like not null just says, hey, this field cannot be left blank. It's all about building a solid foundation. Okay, the blueprint is done. The house is built. It's time to move in. We're switching hats now, from the architect to the homeowner. This is DML, the data manipulation language, where we handle the day-to-day stuff. An empty table isn't doing anyone any good, so the first thing we gotta do is put some data into it. We use the insert command for that. It's pretty straightforward. You just say insert into the table you want, tell it which columns you're filling, and then give it the values. And boom, just like that, our first student, Ravi, is officially in the database. All right, now for the star of the show, the command you will use more than literally any other, select. This is how you ask your database questions. And that little star, the asterisk, that's just shorthand for everything. So when you say select star from student, you're asking the simplest question there is. Hey, show me absolutely everything you've got in that student table. But let's be real, you almost never want everything. You want specifics. And that's what the where clause is for. It's a filter. By adding where city equals Delhi, we're not shouting for everyone anymore. We're asking, can you please show me only the students who live in Delhi? This is exactly how Netflix finds comedies and not horror movies. Okay, so getting the right data is key, but getting it in an organized way is even better. That's where order by comes in. By tacking on order by name at the end, we're telling the database, hey, thanks for the list, but could you sort it for me alphabetically by name? It just makes everything clean and easy to read. So what happens when things change in the real world? Well, your data has to change too. That's what update is for. It lets us pinpoint an exact record. Notice we're using that where clause again to find roll number 1, and then change something about it. In this case, we're setting the fee to a new value. Okay, everybody lean in for a second, because this is probably the most important warning in all of SQL. If you write an update or a delete command and you forget to include a where clause, You're not going to change one record. You are going to change every single record in the entire table. It's a catastrophic mistake, so always, always double check your where. So far, we've basically just been fetching lists of things. But the true power of SQL, the real magic, is when you start asking questions that summarize your data and show you things you couldn't see before. So let's ask a smarter question. Not just who lives in Delhi, but a much more interesting one. How many students do I have in each city? A simple select and where just can't answer that. We need a new tool. Now, if you just stare at the raw data like this, trying to answer that question is a total pain. You have to scan the list with your eyes, keep a running tally in your head. Okay, Ravia's 1 for Delhi. Priya's 1 for Mumbai. Amit, okay, that's 2 for Delhi. It's slow, it's boring, and you're probably going to make a mistake. But watch this. With one simple command, group by, SQL does all that tedious work in an instant. We just tell it, hey, group all my students by their city, and then count how many are in each group. And we get this, a perfect, clean, simple summary. That's the moment SQL stops being a filing cabinet and becomes an incredible analysis tool. Group by is so powerful because it works with these things called aggregate functions. You can think of them as special purpose calculators. We just used count to ask how many, but we could just as easily use sum to get the total fees per city, or AVG to find the average fee. These are the functions that turn thousands of rows of data into one single useful answer. So we've been the architect, the homeowner, and the data detective. We've built structures, managed data, and asked some pretty smart questions. Now, let's zoom all the way out and see why this one language is so incredibly important. Think about it. This language was designed back in the 1970s, and yet it is the absolute backbone of the modern internet. Why? Because it's unbelievably good at what it does. It's fast, it's reliable, and it's built on a simple logical idea of rows and columns. Every time you check your bank account, buy something online, or scroll your social media feed, you can bet there's an SQL database in the background, flawlessly serving up exactly the information you need. And that's really the key takeaway here. SQL isn't just about code and commands, it's about curiosity. It gives us a powerful tool to not just store data, but to have a real conversation with it, to ask it questions, to find the patterns, and to uncover the stories hidden inside. The language gives you the power, but the magic comes from the questions you decide to ask.